Hello students, in the last class we have completed the elementary transformation of matrix. It is considered as 6 total operations concerned to rows and columns. We completed 3 elementary transformation for rows and 3 elementary transformation for columns. In the first step we completed that the interchange of any 2 rows or any 2 columns, and in second step we completed that multiplication of any row or any column by a constant k, and in third step we completed that multiplication of any row or any column by a constant k, and that is added to another row or another column. These are 6 elementary transformation of the given matrix. After that we started one of the example on that elementary transformation, that is find the inverse of the matrix. Find the inverse of the matrix 2 1 3 2 by using elementary transformation. So this we started, and in last step there is some mistake in this example. I will complete that example. Now first we take this given matrix as A equal to 2 1 3 2. It is a square matrix of order 2. Then we know that A can be written as A into I. In identity matrix or multiplicative identity, we know this property. A is always written as A into I. According to this, you substitute the values of A and I. A I will write it as 2 1 3 2 equal to this A as it is. I means it is identity matrix 1 0 0 1. After that we completed column wise transformation. It is C1, it is C2. Here also it is C1, it is C2. Once you start the column transformation, until you get left hand side identity element, we continue the column transformation only. So first we make this as 1. Comparing left and both right side values, we observe that in place of 2 it is 1 in there, in place of 4 it is 0 in there, 3 it is 0, 2 it is 1. Now our intention is to convert this left hand side matrix into identity matrix by using elementary transformation, either row or column, any one. Now I started already column transformation, that is to make it as 1 we taken it is C1 as taken as C1 minus C2. Now we get taking C1 as C1 minus C2, means we transform by using column, that is it is C1, it is C2, it is 2, it is 1, that is 2 minus 1. After that it is 3, it is 2 means 3 minus 2, and second column no change as it is 1 2. In right hand side also we make the same transformation, that is it is C1 minus C2 means 1 minus 0, and second element it is 0, it is 1 means 0 minus 1, second element 0 1 as it is. Now after this we completed. Now here 2 minus 1 is 1, it is 1, 3 minus 2 is 1, this 2 as it is, equal to A into 1 minus 0 is 1 0, second row 0 minus 1 is minus 1, this 1 as it is. Now we got here 1, here also 1 is there. Next to make this element to 0, because it is 0 is there, for that I will take C2 as C2 minus C1. This transformation I will take, taking C2 as C2 minus C1, we get it is C2 we are changing here. It is C1, it is C2, it is C1, it is C2. Now C1 as it is, 1 1 as it is. C2 minus C1 means 1 minus 1. It is 2 minus 1. Right hand side, here also make C2 minus C1. C1 as it is, 1 minus 1, 0 minus 1, and it is 1 minus of minus 1. It is C2 minus C1. Then we get it is 1 0 1 1. It is left hand side. Right hand side is A as it is. Now here 1 minus 1 minus 1. 1 minus of minus 1 is plus 1. It is 2. 1 plus 1 is 2. Now you observe that here 1 0 0 1 is there. Here 1 0 you got. It is here 1 is already there. But we want this also 0. It is possible if you take C1 minus C2, you get here 0 element, then it becomes entity element. Then you make transformation taking C1 as C1 minus C2, we get it is 1 minus 0 is 1, 1 minus 1 is 0, it is 0, it is 1 as it is. Right hand side, it is 1 minus of minus 1. It is 1 minus of minus 1. It is minus 1 minus 2. Now it is minus 1 2 as it is. Second column as it is. We are changing only first column as C1 minus C2. Now what we get here? This is left hand side is 1 0 0 1. Right hand side is A into it is 1 minus of minus 1 is 1 plus 1, it is 2. It is minus 1. Second row minus 1 minus 2 is minus 3 and it is 2. Now here left hand side we get I matrix. It is nothing but I equal to A into it is A inverse, because in invertible matrix we know that it is I value is always equal to A into A inverse. If left hand side is identity matrix, right hand side this matrix automatically becomes inverse of the given matrix. Therefore we say that A inverse equal to 2 minus 1 minus 3 2. Now it is the inverse of the given matrix. It is transformation of column is applied for this example, and by using that we get this one. Now we check whether your answer is right or not. For that we check that A into A inverse. If it is identity matrix, then your answer is correct. Now we make verification. You make A into A inverse. Multiply given matrix with this answer. A is 2 1 3 2. A inverse is 2 minus 1 minus 3 2. Now multiply this row with column. First 2 into 2 4, 1 into minus 3 minus 3. Next 2 into minus 1 minus 2, 1 into 2 is plus 2. First row is second column completed. Next second row with first column. 3 into 2 is 6. Minus 2 into 3 is 6. Next 3 into minus 1 is minus 3. Plus 2 into 2 is 4. Now we get it is 4 minus 3 is 1. Minus 2 plus 2 is 0. 6 minus 6 is 0. It is 1. It is nothing but I. Now we get A inverse into A equal to I. Therefore our answer is correct, because it satisfies the condition A into B equal to B into A equal to I condition, where A is here invertible matrix. The inverse of the given matrix is B. In place of B we get it is 2 minus 1 minus 3 2. This is the inverse of the given matrix. Like this we find the inverse of the given matrix by using elementary transformation. Write this one. Next we go for another example. Find the inverse of the matrix 1 3 1 4 by using elementary transformation. Now we go for solution of this. First you take given matrix as A 1 3 1 4, it is given. Now we go for here elementary row transformation for this one to find the inverse of matrix. I will use elementary row transformation. Now similar to last question, this A can be written as A into I, because A into I is A matrix only. A is given, it is 1 3 1 4 equal to A as it is, I is 1 0 0 1. Now we convert this left hand side matrix into identity matrix. For that, it is already 1 in there. In the last example, this 1 is not there. We converted that into 1, but here already 1 is given. Next, our intention is to make other 3 elements to change. Here first we change this element 1 to 0 because it is 0 is there. Next we convert this 4 into 1. It is second step. Next third step, we convert this 3 into 0. If you change these 3 elements, automatically left hand side becomes identity matrix, then right hand side becomes the inverse of the given matrix. Now first here it is 1 in there, I want to make it as 0. Now it is row element, it is R1 first row, it is R2 second row. Here also it is first row, it is R1, it is R2. First to make it as 0, if you take 1 minus 1, then we get answer 0. 1 minus 1 means it is R2 minus R1. First to take that transformation, taking R2 as R2 minus R1. Then what you get here, 1 3 as it is. We are changing only second row, first row as it is. Here R2 minus R1 means 1 minus 1, it is 4 minus 3. Because it is 4, it is 3. That is 4 minus 3. It is nothing but R2 minus R1. Now right side, it is also changing. First row as it is 1 0. Second row is changing as second row minus first row. That is here also R2 minus R1. That is 0 minus 1. Second element 1 minus 0. 1 minus, it is R2 minus R1. Then we get 1 3 0, 4 minus 3 is 1. Here right side A as it is 1 0 minus 1 1. Now we observe that here we want identity matrix in the left side. 1 0 1 is already there, but we convert this 3 to 0, then it becomes identity matrix. For that, this 3 is present in the first row. Here in the second row 1 is present. To make this 3 as 0, I will take the transformation, taking R1 as R1 minus 3 R2. If you multiply this 1 by 3, then it becomes 3. Then 3 minus 3 is 0. For that reason, I taken this transformation R1 minus 3 R2. Now what we get here? 1 minus 3 into 0. It is 3 minus 3 into 1. It is left hand side. Second row as it is. Here right hand side is also taken same transformation. 1 minus 3 into minus 1, because R1 is 1, minus 3 is constant as it is, R2 is minus 1. Here 0 minus 3 into 1. it is R1 minus 3 R2, second row as it is minus 1, 1. Now left side you get 1 minus 0 is 1, 3 minus 3 is 0, it is 0, it is 1. Right hand side is, it is 1 minus of minus 3 is 1 plus 3, it is 4, 0 minus 3 is minus 3, it is minus 1, 1 as it is. Now we observe that left hand side we get the identity matrix. It is in the form of I equal to A into A inverse form. In place of A inverse, we are observing that A inverse equal to, it is 4 minus 3 minus 1, 1. Now it is the inverse of the given matrix. Now if you want to verify, you multiply A with A inverse. If your answer is I, then it is verified. Now for verification, we do like this. Verification, you consider A into A inverse or A inverse into A, any one. A is 1, 3, 1, 4. A inverse, it is 4 minus 3 minus 1, 1. Now multiply 1 into 4 is 4, minus 3 into 1 is minus 3, 1 into minus 3 is minus 3, 3 into 1 is 3. Second row, 1 into 4 is 4, minus 4 into minus 1 is minus 4, 1 into minus 3 is minus 3, plus 1 into 4 is 4. Now we get 1, 4 minus 3 is 1, minus 3 plus 3 0, 4 minus 4 0, it is 1. It is nothing but I. Therefore our answer is correct because we get the verification A into A inverse equal to I. If you don't get this A into A inverse equal to I, then we check the answer. Somewhere we are having the mistake in that question. Now it is verified. Therefore our answer is A inverse equal to 4 minus 3 minus 1, 1. It is inverse of the given matrix. Write down this. Now we go for another example. Find the inverse of the matrix 1, 3, 2, 7 by using elementary transformation. Now here we take it as A, that is 1, 3, 2, 7. Now here also I apply elementary row transformation for this. For that you take this 1, 3, 2, 7 as A into I. A into I means 1, 0, 0, 1. It is R1, it is R2. Here also it is R1, it is R2. Now first it is already 1 in there both side. First element I will make this 2 as 0. After that this element as 1. After that this element as 0. Then we get left hand side identity element, right hand side is inverse of A element. Now first you make this 2 as 0 by using row transformation. Here 2 it is 1. For that first you multiply this 1 by 2 and subtract with this one, you get answer 0. For that I will take the transformation taking R2 as R2 minus 2R1. Then we get this element as 0. That is first row as it is 1, 3, 2 minus 2 into 1. That is R2 as 2 minus 2 is a constant as it is, R1 is 1. Here also same, 7 minus 3 into 3. 7 minus 2 into 3. R2 as it is 7 minus 2 as it is, R1 is 3. It is equal to A into, here also first row as it is 1, 0. Second row is changing as R2 minus 2R1. 0 minus 2 into 1. Because R1 is 1 here. Similarly 1 minus 2 into R1 is 0. Now it is first transformation. We get 1, 3, 0, 7 minus 6 is 1. Right hand side is A as it is into 1, 0, minus 2, 1. Now it is first transformation. You get left hand side as 1, 0, 3, 1. Now if you make this 3 as 0, it becomes identity element. Therefore, we make the transformation taking R1 as R1 minus 3 R2. Means if you multiply R2 by 3 and subtracting R1 and R2, then 3 minus 3 is 0. Here you want element 0 at that place. For that we take this transformation. Now we get 1 minus 3 into 0. Here 3 minus 3 into 1. Second row as it is 0, 1. Here same operation on the right hand side. Here 1 minus 3 into minus 2. 0 minus 3 into 1. Second row as it is minus 2, 1. Now we get 1 minus 0 is 1. 3 minus 3 is 0. It is 0, it is 1. Right hand side is A into, it is 3. 1 minus 3 into minus 2 is plus 6. 1 plus 6 is 7. 0 minus 3 is minus 3. It is minus 2. It is 1. Now left hand side we get identity matrix. Therefore it is compared with I equal to A into A inverse. Now in place of A inverse we are observing that A inverse equal to 7 minus 3 minus 2, 1. So this is the inverse of the given matrix for the given example. Now if you multiply A into A inverse, again we get the identity matrix only. Verify also that answer. Next we go for another example. It is similar to last question. Find the inverse of the matrix 1, 2, 2, 5 by using elementary transformation. First we consider A. It is equal to 1, 2, 2, 5. Here I will take again elementary row transformation for the solution. Now A equal to A into I. Substituting the values 1, 2, 2, 5. It is equal to A as it is into I is identity matrix 1, 0, 0, 1. Now first element, this 2 converted into 0 by using the elementary row transformation. For that, this you multiply by 2 and subtract with this one. That is R2 minus 2R1. Then we get this element automatically 0. For that, I will taking R2 as R2 minus 2R1. Then we get left hand side. It is 1, 2 as it is first row. Second row is 2 minus 2 into 1. Here 5 minus 2 into 2. That is R2 minus 2R1. The same applied for right hand side. A 1, 0 as it is. R2 minus 2R1 means 0 minus 2 into 1. Next 1 minus 2 into 0. It is R2 minus 2R1. Now simplify 1, 2. 2 minus 2 is 0. 5 minus 4 is 1. Equal to A into 1, 0. It is 0 minus 2 is minus 2. 1 minus 0 is 1. Now it is first transformation. Now we observe that right hand side it is 1, 0, 0, 1, but here 1, 2, 0, 1. In place of 2 you want 0 element. For that you make this 2 as 0 by using row transformation. How it is? That is R1 minus 2 R2. Multiply this R2 by 2 and subtract with R1. Then you get R1 minus 2 R2 as 0. For that we take the transformation taking R1 as R1 minus 2 R2. Then we get 1 minus 2 into 0, 2 minus 2 into 1. It is first row. Second row as it is 0, 1. Right hand side also same. R1 is 1. 1 minus 2 into R2 is minus 2. It is R1 minus 2 times of R2. Similarly for the second element 0 minus 2 into 1. Second row as it is minus 2, 1. Left side we get 1 minus 0 is 1. 2 minus 2 is 0. It is 0. It is 1. Right hand side is A into 2 minus 2 into minus 2 plus 4. 1 plus 4 is 5. Next element 0 minus 2 is minus 2. Second row as it is minus 2, 1. Now left side we get identity matrix. Then we compare this with I equal to A into A inverse. Then in place of A inverse we get A inverse equal to 5 minus 2 minus 2, 1. Now it is the inverse of the given matrix 1, 2, 2, 5. Now if you verify A into A inverse, automatically you get the identity matrix. That is the verification. Write this one. Now we go for another example. Find the inverse of the matrix 1 minus 1, 2, 3 by using elementary transformation. Here A is given 1 minus 1, 2, 3. It is a given matrix. Now we can write this as A equal to A into I. That is 1 minus 1, 2, 3 equal to 1, 0, 0, 1. It is identity matrix multiplied with A. Now here also we go for the similar step. First we make this 2 as 0. Next in this place we make it as 1. After that in this place we make it as 0. Then we get the identity matrix left side. Automatically right hand side becomes inverse of the given matrix. Now first we make this element as 0. Here 2 it is 1. It is similar to last question. For that first we taking R2 equal to R2 minus 2 R1. Then we get it is equal to 1 minus 1 as it is first row. Second row R2 is 2. 2 minus 2 into 1. It is R2 minus 2 R1. Similarly for this element, first we write 3 minus 2 as it is into R1. R1 is minus 1. Now we write it as minus 1. It is nothing but R2 minus 2 R1. Similarly for right side, A as it is, 1, 0 as it is. Here we are changing second row, R2 minus 2 R1, 0 minus 2 into 1. 0 minus 2 times of 1. Next 1 minus 2 times of 0. It is R2 minus 2 R1. Now simplify. It is 1 minus 1. 2 minus 2 is 0. 3 minus of 2 minus of minus 2. That is 3 plus 2. 3 plus 2 is 5. Now it is equal to A into 1, 0 minus 2. 1 minus 0 is 1. Now in previous all the example we directly get this element as 1, but here it is equal to 5. First we convert this 5 to 1, then we get the remaining part of that one. For that, whatever this element is present other than 1, directly we divide that element by whole row, then we get that is equal to 1. For that I will take the transformation taking R2 as 1 by 5 into R2. The same element you divide for whole row, that is second row, then we get it as 1 because 5 by 5 equal to 1. Suppose it is other than 5, you divide by that element only. Suppose here 6, you take 1 by 6 R2. Suppose it is 7, you take 1 by 7 R2 like that. Then it becomes 1. For that reason you divide by directly this element for the entire row. Then we get it is 1 minus 1 as it is. It is 0 by 5. 0 by 5 it is 5 by 5. 1 by 5 into 5 is 5 by 5. Right hand side A as it is. Now first row also as it is. Minus 2 as it is into 1 by 5, that is minus 2 by 5. That is 1 into 1 by 5 is 1 by 5. Now we get second row as minus 2 by 5, 1 by 5. Then here left hand side changes to 1 minus 1, 0, 1. Right hand side is A into 1, 0, minus 2 by 5, 1 by 5. It is as it is. Now we get left hand side as 1, 0, 1 here, but now we want this element as 0, but here it is minus 1 is there. You convert this minus 1 into 0. How can you convert? If you add this and this, minus 1 plus 1, you get answer 0 here. For that, just you add these two rows, R1 plus R2. If you make R1 plus R2, you get minus 1 plus 1 is 0. Then automatically you get left hand side as identity element, that is 1, 0, 0, 1. For that reason, here you take the transformation, taking R1 as R1 plus R2. If you take R1 plus R2, you get here it is 1 plus 0 minus 1 plus 1. Second row as it is equal to right hand side. Here also you make it is R1, it is R2. Here also you make R1 plus R2, that is 1 plus minus 2 by 5, that is 1 minus 2 by 5. It is this plus this R1 plus R2. Here 0 plus 1 by 5. 0 plus 1 by 5. Second row as it is minus 2 by 5, 1 by 5. Second row is as it is. Now left side we get it is 1, 0, 0, 1. Right hand side it is simplified. LCM is 5. Here it is 1. It is multiplied by 5. That is 5 minus 2. It is 0 plus 1 by 5, 1 by 5. Minus 2 by 5, 1 by 5 as it is. 1, 0, 0, 1 equal to A into 5 minus 2 is 3. 3 by 5. It is 1 by 5. Minus 2 by 5, 1 by 5. Now left hand side is nothing but identity matrix. Now we compare this with I equal to A into A inverse. Now A inverse is nothing but A inverse equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. This is inverse of the matrix. Now you take 1 by 5 common, because it is every element is multiplied by 1 by 5. For that you take outside, then you get 3, 1, minus 2, 1. This is inverse of the given matrix. For verification, if you multiply this A inverse with A, automatically you get identity matrix again. That is the answer for given question. Write down this. Now we go for one important theorem, which is very important for 3-mark question. If A and B are invertible matrices of the same order, then prove that AB whole inverse equal to B inverse into A inverse. It is important theorem, that is for 3-mark question. Now we go for proof of this one, proof of this theorem. We can use some of the previous results for proving this theorem. Now we know that A inverse into A equal to I, that is definition for invertible matrices. If A inverse into A equal to I, then A is inverse of this one and A inverse is inverse of A1. Like that we multiply, if A inverse into A equal to I, then automatically it is invertible matrix. Here in this theorem we observe that left side is AB inverse, right hand side is B inverse into A inverse. Now by comparing these two, we can take A equal to AB here. For this side we get AB inverse into AB. That to consider it as left side. It is simplified according to this one. Then we get the answer for this theorem. Now we simplify this by using the property of this A inverse into A equal to I, or we may write A into A inverse is equal to I. If we substitute here AB, we get AB into AB inverse equal to I. Both are same. Now we simplify this by using some of the elementary operations and we get the proof of the theorem. Now I will consider this one AB into AB inverse equal to I. It is by definition of invertible matrices. Now I am multiplying by some of the element on the left side, multiplying by A inverse on both sides. That is called pre-multiplying on both sides. Then we get A inverse into AB whole inverse equal to A inverse into I. This is called pre-multiplication of A inverse on both sides. Then we apply the properties of multiplication of matrices. Now it is written as A inverse into A inverse into A into B into AB inverse equal to A inverse into I. Now which property applied here? Because it is in the form of A into BC, I written as AB into C. A into BC equal to AB into C. It is assertive property of multiplication of matrices. Now as we know that A inverse into A equal to I into B, we get here AB whole inverse equal to A inverse into I. It is as it is. Now reason is we know that A inverse into A equal to I. By using this we get this step. Now we already know that multiplication of any matrix by identity matrix is same matrix, that is multiplicative identity. Here I into B is B into AB whole inverse equal to A inverse into I is also A inverse, because we know that I into A equal to A into I equal to A. It is the property of multiplication of matrices. By using that we get this step. Next, for getting the right hand side B inverse into A inverse already got. We want B inverse into A inverse. For that we pre-multiply by B inverse on both sides. By pre-multiplying by B inverse on both sides. What we get? B inverse into B into AB inverse equal to, we get B inverse into A inverse. Now both sides are multiplied by B inverse, that is on left side. Now we get B inverse into B. B inverse into B is nothing but I into AB whole inverse equal to right hand side is B inverse into A inverse as it is. Now identity matrix into any matrix is same matrix, that is AB whole inverse equal to B inverse into A inverse. Here the result is B inverse into B equal to I. Again it is the property of that is invertible matrices, that is B inverse into B equal to I. Here I into AB inverse is AB inverse. Here also same property, I into AB whole inverse equal to AB inverse. Now we get AB whole inverse equal to B inverse into A inverse. which is the proof of the theorem. Now just simplify by using the condition that A into N is equal to I. In place of A, you consider AB in the left side. Then we get AB into AB is equal to I. First we multiply by A inverse on both sides. Then apply the associative property and identity property. We get B into AB inverse equal to A inverse. After that you multiply by B inverse, multiplying by B inverse on both sides. Then you get B inverse into B, which is nothing but I. Then left hand side becomes AB inverse, right hand side becomes B inverse, A inverse. It is simple trick for proving the theorem. Like that you prove the result by using some of the important results. Add this one. Now take some of the assignment examples. First one, express the following matrices as a sum of symmetric and skew symmetric matrices. First question, 3, 4, minus 1, 2. Second one, 5, 2, 3, 1. The second one, find the inverse of the following matrices by using elementary transformation. First question is 1, 5, 1, 6. Second one is 1, 1, 8, 7. These examples can solve by using the previous examples. With this chapter is completed. That is matrices. In the next class we go for that is new topic, that is determinants.